So right before I start this tutorial, I have to do this. That looks better. So what's the ideal shutter speed for shooting Milky Way images? Let's find out. Hey guys, welcome back to my channel. I am Rajesh and you are watching Quick Tip Milky Way. So in this tutorial we are going to talk about shutter speed for Milky Way photography and also some other interesting facts which I recently noticed. So without wasting any further more time, let's get started. So first things first, what is the ideal shutter speed for shooting Milky Way images? Well, that depends upon two things: the focal length at which you are shooting and U factor. Now the second part, the U factor, is very interesting, so please watch this video until end. Now let's talk about the first part, that is the focal length. Now your focal length will actually tell you the shutter speed for shooting Milky Way images because your shutter speed is directly related to focal length. Now how is that? Well, we all know that Earth rotates, and as the Earth rotates, we can see the motion of stars, or we can see the stars changing the position in night sky. So if you shoot a very long exposure, you will notice the stars are getting trails. That is because of Earth's rotation. Now, if I am trying to shoot Milky Way, I won't like the star trails in my Milky Way images because that is something different than what I am trying to shoot. Hence, I need to find maximum shutter speed before I start getting star trails. So, to determine this, there is something called as the 500 rule. Now, what is the 500 rule? Now, the 500 rule states that if you want to get pinpoint sharp stars, that is stars without trailing in your Milky Way images, then you have to divide 500 by your actual focal length. Now, what is actual focal length? So for example, if you are shooting on a full frame camera, so for example, I am shooting with my Sony a7R III at 17mm. So 17mm is my actual focal length. But I am shooting with my Nikon D5200, that is a crop sensor camera, then the actual focal length changes. So for crop sensor cameras, the actual focal length is the focal length into crop factor. Now there are multiple crop factors for multiple camera brands. For Nikon, the crop factor is 1.5, so 18mm into 1.5 is 27, so 27mm is my actual focal length. So for my full frame cameras at 17mm, 500 divided by 17 gives me 29 point something, so I can approximately round it about for 30 seconds, and 30 seconds will be my shutter speed. And for crop sensor camera, if I'm shooting at 18mm, then 500 divided by 27, which is the actual focal length for crop sensor cameras, gives me about 18.5 seconds or something like that. So I can round it about at 20 seconds. But I'd recommend use something less than what the 500 will actually suggests you. So your actual focal length is actually the focal length at which you are shooting Milky Way images, and if you divide 500 by your actual focal length, that gives you the maximum shutter speed which you can use for your Milky Way images before you get star trails. So that was about the first part. Now let's talk about the most interesting part, the U factor. The U factor. Now what is the U factor? The U factor is something which I follow and which I have made up. I was shooting Milky Way with my Nikon D5200 for past 4 years or so, and now I have upgraded to a full frame camera, that is my Sony a7R III. But when I was shooting with my Nikon D5200, I learned to compromise with shutter speed. Now what do I mean by compromise with shutter speed? Let's have a look at this image here. So this image was shot with Nikon D5200 and Tokina 11-16 lens at 11mm. So at 11mm, that gives me 30 seconds of shutter speed for shooting this image, and which I did. I followed that rule, I got 30 seconds of shutter speed, and I shot this image at 11mm using 30 seconds of shutter speed. But if you look at the image looked perfectly fine. There's no trailing in the stars, the image has good details, the Milky Way is looking very good, the frame is good, everything is good. But when I zoom into the image, there's trailing. So there's a bit of trailing happening in this image, and the reason is the same thing, the rotation of Earth. So even though I follow the 500 rule, there is a bit of trailing, which is why I would recommend to follow something less than the 500 rule. But the thing is, when you look at the image, you won't notice star trails. But what you'll definitely notice is the details in the Milky Way. I have got good details in this image. I have very good details in my Milky Way image, even though I shot this image with a crop sensor camera and Tokina 1116. Hence, I have to make choice between good details in my Milky Way images or pinpoint sharp stars, and definitely I will choose good details in my Milky Way images. Thank you so much for watching this tutorial. If you like the tutorial, then please let me know in the comment section below, and I'll be making more such tutorials for you guys. And that's where I leave you guys. See you in the next one.